Hello friends, myself R.D. Mahajan, Assistant Professor MIT Aurangabad, presenting my video on the topic Heaviside unit step function and displaced unit step function. Point from first unit Laplace transform. Heaviside unit step function, it is denoted as U of t. U stands for unit, or H of t. H stands for Heaviside, and defined as U of t having two values, 0 for negative values of t, and it is equals to 1 for all positive values t greater than or equals to 0. The same we can represent in terms of figure. On x-axis we take the values of t, on y-axis we take the values of f of t, and the function value is here 1. And therefore on negative side no any part of the curve appears, therefore its value is 0, and from 0 onwards up to positive infinity the value of that function is 1. It is called as unit step function or Heaviside unit step function. After defining it, we try to see how we can obtain the Laplace transform of it. Therefore, Laplace transform U of t. We take the help of the basic definition of the elementary definition to find the Laplace of unit step function. As per definition, it is integral from 0 to infinity e raised to minus st into that function U of t, and it is equals to integral from 0 to infinity e raised to minus st. The function value of U of t between the range 0 to infinity, its value is 1, and therefore we substitute that value here as 1, and its integration with respect to t. This becomes e raised to minus st. Its integration is e raised to minus st by minus s, and limit from 0 to infinity. And therefore it is equals to 1 by s I can take outside, and minus sign we can cancel by changing the limits. This become upper, this become lower. Therefore e raised to 0 minus e raised to minus infinity, and therefore we get 1 by s. E raised to 0 is 1, e raised to minus infinity is 0, and therefore its value is 1 by s, and therefore we get the first result, Laplace transform of unit step function is 1 by s. We get this one. This is the first result from this section. This function is a discontinuous type of function, or we can call it a special function, like periodic function. In the previous videos I have discussed how to find Laplace of periodic function. Like that, we try to see how we can obtain the Laplace of unit step. Displaced unit step function denoted by U of t minus a or H of t minus a. Its definition is U of t minus a having two values, 0 for t less than a, and second value is 1 for t greater than or equals to a. The same we can represent in terms of figure. On x-axis we take the values of t, on y-axis we take the values of f of t. The value of this function towards left of a is 0, and towards right of A or A onwards its value is 1, and that function is denoted as u of t minus a or h of t minus a, known as displaced unit step function. Therefore, whatever the unit step function we have discussed earlier, it is displaced by a distance a on right hand side. Okay, and then we try to find Laplace transform of u of t minus a. Laplace of u of t minus a using basic definition or elementary definition. It is integral from 0 to infinity e raised to minus st into that function u of t minus a and its integration with respect to t. It is equals to this 0 to infinity we have to split as integral from 0 to a and integral from a to infinity. In between 0 to a, the value of that function is 0, therefore into 0, and e raised to minus st, and from a onwards up to infinity its value is 1, therefore the value of u of t minus a we substitute as 1. Okay, and therefore it is equals to this becomes 0. Integration of this is e raised to minus st divided by minus s and limits from a to infinity. It is equals to 1 by s I will take outside as it is constant. Minus sign we cancel by changing the limits. This become upper, this become lower. Therefore, for upper limit, it is e raised to minus as, and minus lower limit as infinity. Therefore, e raised to minus infinity, and it is equals to 1 by s e raised to minus infinity 0 into e raised to minus as. Okay, and therefore we get Laplace transform of u of t minus a is equals to e raised to minus as divided by s. Okay, we try to see some cases for multiplication. Here multiplication by continuous function f of t to unit step function u of t. This is the continuous function f of t. On x-axis we take the values of t, on y-axis we take the values of f of t. The points on that are a, b, c, d and e, and on x-axis we have 2 points a and b. Means for point c corresponding value is a and for point d corresponding value is b on x-axis. This function is a continuous function that is multiplied to unit step function u of t. On x-axis t, on y-axis f of t, and the value of that function is 1 for all positive values of t, and its value is 0 for negative values of t, as that already I have explained in the previous part. Therefore, we try to see the multiplication of f of t to u of t, and to find the value we consider the values of u of t. We are having two values for u of t, 0 and 1. Therefore, when it is 0, this product becomes 0 for the condition t less than 0. For negative part, it's become 0. Second value for u of t is 1 for positive values of t. Therefore, 1 into f of t we get as f of t for condition t greater than or equals to 0. The same we can represent in terms of figure. Therefore, after multiplication of these two, this part vanishes or becomes 0. And therefore, from point B to point E, whatever that portion of the graph f of t that represent a product f of t into u of t. Therefore, this part vanishes. Okay. Therefore, from point B to C to D and up to E, that part of this function f of t is the product of f of t into u of t. And then we try to find out the Laplace transform of u of t into f of t. And we apply the basic definition or elementary definition. It is integral from 0 to infinity e raised to minus st into that function. That function is here u of t into f of t. Its integration with respect to t. And then it is equals to zero to infinity e raised to minus st, and u of t into f of t is nothing but f of t for the range 0 to infinity, as I explained in third figure. Okay, and then this is the definition of Laplace transform of f of t. Okay, 0 to infinity e raised to minus st f of t dt is Laplace transform of the function f of t, and therefore Laplace of f of t we are denoting by f bar of s. Okay, and therefore we get this result, Laplace of f of t multiplied by some unit step function u of t is equals to Laplace of this function f of t as f bar of s. Therefore, we have a standard result. Okay. Therefore, this is case number 1. We try to see case number 2. To displace unit step function u of t minus a. Therefore, that displace unit step function as shown in this figure, this exists from a onwards towards right hand side. Value of that is 1. Therefore, we know the definition of that unit step function. U of t minus a are having two values, 0 for t less than a, and its value is 1 for t greater than or equals to a. And this way to multiply to continuous function f of t. And therefore, if we try to perform this multiplication, f of t multiplied by u of t minus a, and to find the value of this, we take the help of this function value. When it is 0, this product becomes 0 for t less than a, and it is equals to, when its value is 1 for t greater than or equals to a, this become 1 into f of t as f of t for t greater than or equals to a. Therefore, these are the values of this product. The same we can represent in terms of figure. Means the part of this continuous function towards left of a vanishes, and therefore the resultant figure we can show like this. Same figure, but we have to remove this part which is on left hand side of a. Therefore, that point B to C vanishes. Okay, this vanishes, and whatever the curve we have, therefore this is the point A, this is point B. On y-axis we are taking the values of f of t, 0. This point is B, this point is C, D and E. Therefore, this much part becomes 0 or vanishes. Therefore, this curve from C to E, or the portion of that f of t between C to E, represents the product of f of t into u of t minus e. Therefore, this is case second. Okay. Remaining cases I will explain in second part of this video. In next part I will discuss the third case, multiplication by continuous function f of t minus a into u of t minus a, and like this. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel for latest updates. Thank you very much.